Boop, 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 boom. All right, I'm back, but the stream ended, so this is a new stream now. I just had the power. The power just went out. So that's what happened. Wait, what's this thing on the bottom? What is that? Oh, wait. It's because this is too big. Font size 70%. Does that work? Should it be in quotes? Transform scale 0.7. I don't know. How do you make the HTML page look smaller? Just at this point over there, maybe. Okay. Alright, sorry about the stream crash. Let's move on with the thing that I was doing over here. We're talking about tokens, parts, push back. It's just ignored. Token. There we go. And then the span. Okay. Span is start is syntax token is peak, right? So I say syntax token span start end. You know what? Let's just say span is syntax token span, and over here we say span end is token span end, right? And this is how we get the span of the whole error, and we return the fact that we made progress. All right, let me compile, and the LSP should not crash anymore. And this advance is going to be actually the regular token stream advance now. We are back. Yes, we're back. I just had the power. The power just went out, unfortunately. Alright, I'm just going to finish this thing, which is making ignoring more errors when we need to ignore them. What are you saying to me here? Shape. Ignored token. Oh, we have ignored tokens before. Ignored tokens before is... I have claimed them already, so that's what we have. Okay. Okay, so now we can say this: cast parse the mini syntax, right? And this still works, even although this is not correct syntax, right? We have errors. This is unfinished string, but we don't care about that. We still can do stuff. Right, so this is important for the language server. Language server should never crash. Normally, we obviously stop on error. Right, this tells me that there is an error here now. Unfinished string. Okay, so I was doing that. Okay, let me do this, do that, do that. Okay. Handle errors on when parsing syntax like this. Okay, let's keep working on the this stuff. Right, so we have enum union. This over here, I'm making the minified. Once again, I'm making minified version of Kast, which is going to be used as the intermediate compilation language. Right, so here's what I want. I want to have the enum. So this is me defining an enum. This is going to be const. Const name is equal to enum should we use the round brackets here? Enum. I mean, maybe we just have the variants here. Sure. We compose the syntax out of the simpler one. So we have enum, we have union, which is going to be union, low ICS blinks, and we have a struct. Enum and union. Use AFK. Well, yes, I'm making a mini Kast, okay? Not Kast, but I'm making mini Kast. Once again, the goal is to compile Kast into mini Kast and then compile mini Kast into the compilation target of choice. Right? Mini Kast has more features than Kast. Well, it's a more lower level language, I guess. So, like, I have to do... Like, I mean, I can get rid of the enum and just use the numbers, but I feel like enum is better because like in JavaScript backend, I can use like the symbols instead of just numbers, right? For better debuggability. So I think an enum makes sense. It's also going to be more type safe than just using numbers, right? Union is like the one that is not discriminated, so accessing a specific field, just like in C, would be undefined behavior if you don't access the one that is actually active. Right? This seems like an excuse to make a new language. Yeah, I guess. It's just that, instead of rewriting the whole cast, I can rewrite just this low-level part and then write the compiler and then like fix the speed of my current JavaScript transpiler instead of fixing it in the bootstrap, you know, or like make the at least like we can make the compiled code faster by changing the compilation target from JavaScript to something else, right? Without rewriting the whole language for now, because transpiling into this minicast is going to be basically, I think it's going to be even easier than to JavaScript is the idea, because we will still have the concept of place expressions and point and references, I guess, and then we will like, yeah, something like that. Okay, how do I make this to not report me the errors though? Because this is thinking that it's cast, but this is a mini cast. So how about maybe we change maybe we change the extension to be MKS as microcast, right? Minicast. And we could have a microcast later when we want like to do even lower level, because I think this one will still have the closures, for example. I guess, you know? So MKS. What if I make an extension, the VS Code extension, to also say extensions KS. Do I add it to like the same one? I think I just added to the same one. It's going to be an extension MKS here, right? And then extension TS language server just works for this, and then the language server will know it based on the extension which one we should parse. Maybe let's do this. Reinstall the extension. Let's do the LSP. The LSP will have the LSP right now has the syntax rule set. Let's just call it syntax. Let's just call it syntax, because now we have multiple syntaxes, right? We have the cast, and then we will have the mini cast. Let get syntax path into let's do that. Let's say cast is get syntax. this, and mini cast is syntax source mini syntax. Maybe I need to move this to somewhere it's not in the tests. State syntax cast mini cast. So we are parsing using the syntax rule set, which is depending on the URI, right? So we say a rule set. Yeah, how about this? Rule set is we're going to match. No, not match, right? We're going to say that if, let's say extension. Extension is I have URI. URI has a path, and then we do do we have ends with or something? We have last index of contains find match to ASCII lowercase. No, we don't have the end with. All right. If path let's see, get extension is a path which is a string, right? And this should return an optional string, I suppose, right? So we will say that last dot, I guess, right, is path string last index of a dot, right? If last dot is less than 0, then we return none. Otherwise, we return path substring from last dot plus 1, like that. Logo for minicast. Just make it a small logo. So yeah, we basically say if std wrapper structurally equal get extension of the URI path and some MKS, right? Then this is my rule set. So in this case, it's going to be state syntax minicast. And in this case, it is state syntax cast. All right. And this should be able to parse also. Do you have a syntax error somewhere? This is supposed to be highlighted. Why is it not? Like, it stops. Oh, because syntax. Wait, is syntax a keyword? Is syntax a keyword? No, syntax is identifier. Oh, it's over here in the LSP. Wait, what? Wait, syntax is not a keyword, is it? Oh, wait, it is because I have impulse syntax. Oh no. Okay, it's okay. We're just going to use the row identifier here. We will change this to be an optional keyword. It says 25 seconds. It's like slower and slower every day. The time required to compile this thing. Restart language server. Let's see. Is this going to be parsed now? There you go. Look at this. Now we can parse the minicast. But so in minicast, for example, the syntax is not a keyword, right? And things like match don't exist either. But we have enums, unions, and structs. Okay. All right, so now we can start making the actual language, right? Let's start with what? So what do we call it? Like still the intermediate representation or something? Like what do you call? Let's call it intermediate representation for now. But maybe I will change it to something else. So what I want is I want to have the in this language, it's still going to be expression-based language, so we'll have the expression, right? We'll have expressions. We'll still have the spans for them, I suppose. Shape, expression, shape. Expression shape. New type. Right, so let's see. We will have like an expression which is how do we start? Like with constants? I don't want to have like values here, I think. Because we will not have the I mean, I can have the interpreter for this, but what do I say? I don't know. Well, we will have like the ability to call a function. We call it apply, right? Function is expression and arguments are expression. So arguments are going to be actually a list of expressions in this case, I guess. Function arguments. Sure. Let's do something like this. What we will have? We will have types. Maybe type is a better thing to specify. Type is boom boom. if I don't have the interpreter, I don't even need like to know about the target too much. I feel like all I need is to know opaque types, kind of, for the at the beginning. Maybe for some literals we would want to check the types still. Make when you cast exactly like C and then say abracadabra and make sure you have a C target. I think it's going to be closer to Go than C in terms of semantics. So it's just like a syntax, a different syntax for Go, kind of, maybe. And I am considering transpiling to Go instead of C. So we will have, hold on, what is the result of like my compilation of me like parsing the file and like type checking and everything? That is the what I call the internet representation. So we will have a program basically, and the program will have all of the different types that we should have, right? Which is going to be a map from a string to a type, right? It will have types, it will have functions, which is also a map from string to a function. So we need to specify what a function is. A function has body, which is an expression. A function has arguments, which is an array list of argument, where argument is name and type. Yeah, we need to call it tie. That okay. Right, so we have arguments, which is a list of arguments, and the result type, which is a type, and then the body, or I guess we could, yeah. Arguments, they do have the names. Function argument, let's call it function argument. Well, I will have the type, which is a function type though. Function, which has args, which is a array list of types, and the result, which is a type. And expressions can be like the statement list. That's what we call then in Kast. Where we on the last one is the result, right? Then, which is an array list of expressions. That's how we chain them. Let's have the compiler. What I want is to basically compiler, in this case, is the process of converting AST into the program, into this program here, right? Let's do that. So this is what we want to write. So now, basically, what do we expect on the top level? On the top level of the minicast, it's just a sequence of things, and every one of these things is either a definition or a top-level code, which just goes into main, basically. I don't think I want to have a special main function. Just put the code into the top level is okay. Right? So here's what we want. I want to expect this AST. I want this. I want to create an iter list of AST with binary rule name and trading or leading rule name, right? AST iter list. AST binary rule name is going to be equal. Let's open syntax. So use statement and then basically binary rule name is core then. Trailing or leading is some core statement. For item in this. So we will create the result program immediately, right? Which will originally have types, which is an empty map. Functions is an empty map. And I guess also we also have like the main, which is the code, which is basically just going to be an expression. Right? So, I mean, main is like specifically the, could be a then expression, you know? Could be an array list of expressions. So main is array list new. Sure, let's do that. So now over here, we need to see what is the item that we have. Right, so we're going to match item. Item, this is the AST, so item shape, we're going to match that. And if this is a rule, right? So we need to detect if we are defining a function or a type or things, right? A rule. root. So we say that if rule name is equal to core files. Just have core enum union struct, right? Enum. Then it's an enum. Enum union struct. What else do we want? I mean, in any of these cases, I'm going to continue the loop. I guess. So this is the type definitions that we have. Still have a new type. I think. Well, we'll see. We'll have like top level function, maybe. Like that's a special syntax, right? So, okay. In this case, we want to parse. We want to basically have the type. Actually, hold on. Here's the question, right? How do we resolve this symbols is going to be the important part, right? Shouldn't we just know all, like, the only because I want the function to be recursive, right? It means that we need to first parse all of the top level, like, types to know the types of everything, and only then parse the definitions of them, right? Maybe I do want to have a main then, actually. So that we only allow certain things at the top level. That will probably be easier, actually. Right, we just have main is a function that does this print hello world. So we only allow certain things in the top level. Right? So we need to do basically a two-pass thing. First, we need to figure out the types, like first I need to figure out the types of all the functions, and only then I can compile the functions themselves. Right, so we don't do a single top-down anymore. Same with types. because the types can be recursive. Right? So I think we will need to have something like this. We have top level items is array list new. What is the top level item that we have in general? Top level item is, we have either, yeah, so like we will have a type, a definition, which will have name, and then the definition itself is going to be actually the AST. That's what we were going to store there. Then so like enum union and struct is the type, and then we also have the function, right, which also has name. And the definition. Is that what I want? Type. And over here we have kind. So it's type kind. Type kind. Enum struct union. Is that what we want? I don't know. Maybe. So we just say that over here we say no, we have top level items push back that type the type which has a name, which is root children tuple get named name wrap dereference definition is enum. Let's just have the definition here, union definition. Just have name and we have definition. Wait, why did the formatter get rid of all the syntax? That's not how the syntax is supposed to work. Hello? Oh no, I broke something. I think. Name and definition. So this name, this is children. This is going to be AST unwrap child value. This is just the AST. And this is supposed to be a string, right? So AST to AST as string. AST a string is AST into string. This is going to be match AST shape with token shape is string, contents we ignore everything else, so this is just returning the contents. If anything else, then we like panic. Expected as string literal. Should function have name and definition? I'm not sure if that's what I want to do. Like when type contains an inner type, what do? I just refer to it by name. Maybe. Instead of like by reference. Right, so like for example, doesn't. All is going well. We're just getting started here with minicast development. Like this over here, the function arguments, should this be a type, which means that this is a recursive type, or should this instead be like the name of the type? That's the question, right? I feel like this can be the name of the type instead. So let's call it type name. But I will say that type name is... We will do a new type where just name is a string. There we go. So we will refer to by name. Refer to it by name. And the name basically must exist in the program. This type should have been defined here. And same goes, I guess, when I... So when I apply a function... Now, this can be an expression, right? But just the expression would be what? Just like a name, I guess, right? Identifier. So this is the type definition basically, And this is the type name, which is how we reference other types. Type definition. And this is the function definition. Okay. So I want to extract this to a function. Because we will have the same in other types, right? So we return name and definition here. Hello, ready side. So when we see the enum, we just say that name and definition is name definition of the we take from the root. And then we push back the type. So type is going to be name definition, but it is also going to be kind, which is in this case enum, right? How about we do this? Let parse. Yeah, actually, yeah, let's do this, you know. Let's have it instead be a closure here. Right, type definition. When we have a type definition, we basically have like the root, and we also have the kind, which is type kind, like that. And then this is where we do this code, you know. So we have kind definition like this. So instead of this code, we say type definition enum, right? This over here is going to be union, and this over here is going to be struct. So we are collecting all of the things in the root first, and this over here is going to be the function definition. Let's just continue for now. If it's anything else, though, if we don't continue here, we're going to panic. Unexpected top level item. I need to actually use the errors and stuff. But let's make sure that, like, we at least, like, start doing these things, right? Compile AST. Okay, let's say this is going to be compile AST. Like the full compile is going to be what? I want to compile source, right? Where we have source, and this should return the program, right? Which means that we need to convert this into the AST. So this is similar to something like that, where we need to create the lexer and then like parse things. So create the lexer from the source, Then we have the rule set, and the rule set is parsed from the syntax here. So we source read, source file plus syntax ks. Hold on, syntax path. Syntax path is std path their name of file plus syntax ks, right? That's what we want. So we're parsing the syntax. That is my rule set that we can use to parse the actual source. And then we compile ast, parsed ast. There you go. So that's what we want. So we will have, I think what we want is we want to have another subcommand called mini. So we say cast mini. And over here we have mini args parse. Let's add the mini in the command line. If we have the mini args, then we mini run. Okay. So let's see, what do we want for the mini stuff? We don't want the rule set path. We want a single path to compile, probably. Right? Well, I mean, also we want actually to have subcommands here, I guess. We don't have the arg, which is this. We just have the path. Yeah, maybe we can do like multiple paths and we will just combine the things together. That actually makes sense, I guess. That way we can split in multiple files, multiple things, maybe. Okay, so we have the we don't have the rule set path, and then we process. I don't process the std in. In this case, I panic. Expected at least one path, I guess. So now for every, yeah, we just source read here, and then we say mini compiler compile source, and this is the program that we get as a result, right? And then let's for now dbg print program, I guess. We will see the inner representation, and that's okay. Or wait, like if I want to combine multiple files actually, which does make sense here, then it means that the API should be what? Like we need to basically initialize the compiler, right? So this is the compiler state. Which has something there. I guess the state is the thing that has the top level items, you know? That's all that we want. Top level items is state is a array list of top level items, basically. Top level items is a new array list here. And then I don't say compile source, right? I instead say add source to the state, right? So add source AST, state parsed AST. And this over here is going to be called add source AST state to the AST. This does not return the program yet. And then we process the definitions when we say compile. So we are basically create the compiler state, we add a bunch of sources, and then we compile, right? And this is what should return the program. So we don't say top level items, right? We say state top level items, pushback type. And so in the compiler mini, we can have the libks, I think. And this is what re-exports everything. So we'll say module mini, which is a module, and this is going to import inside and re-export the compiler. And I guess the intermediate presentation too. So when we have the CLI mini, we are going to use import mini lib. Okay, let's see what's going to happen here. I need to import things, probably. Maybe some other things, right? In the intermediate presentation, I don't think I mean, I just need to import the ord map. I also need to import the span, it seems. If I want to maintain the span information, which I think I want to keep the span information, right? Sure. Yeah, so this is the span. And in the compiler, I'm using parser, lexer, source, lexer, parser. I also will need the token stream. I import AST already. Maybe something else. Tuples. Okay, and maybe instead of panicking, we immediately do the diagnostics so that we can like continue on errors. I don't know if I want to continue on errors here. Maybe. Children. Yeah, this should be like reference, and then we dereference. And ISTS string is after dereferencing also. So I will want to import the diagnostic. And instead of panicking, EST string, we say, what if minicast ends up becoming the best language, the higher overthrowing the father? I don't know. I think it's highly unlikely. I mean, I can see how some people could like that. Maybe what I'm trying to create here, because this is like, because some people like C, right? And some people like Go. So diagnostic should have a new source, which is going to be the compiler. I want to create the diagnostic, right? Error, compiler message is current output, which means that I need to import the output, by the way. I also had the reference error. Unwrap child value, or is unwrap child value something that needs to be happening over here? Maybe. Hello, Athano. Expected as string literal. How about st as string? Let's say expect string literal. There we go. Diagnostic. Severity source message. Is there anything else in the diagnostic? I don't remember even. Span and related, right? Related is nothing. Span is AST span. There we go. History tells us the small mini lang that was made in a week will always succeed against the big proper projects. So we keep it a secret then, right? So that it doesn't succeed on accident. There is no shortage of languages, but there is a shortage of backends. Yeah, I guess like this minicast is something similar to the C++ that we were looking at previously, but like more high level. Right? Is what I want. String and ASD is not a unit, because type def doesn't actually return anything. And this should be a let and not a const. Is there another panic? There is another panic. Unexpected top level item. Let's make this a diagnostic too. Unexpected top level item. Item span. One requirement is also that it has to be crappy. Do we have information on how long did it take for the original C compiler to be created? How long did it take to create original first version of C compiler? Like, it was created in the 70s by Dennis Ritchie, but the first year was about 3 to 4 years. Okay, I thought it was also, like, because it's a simple language, I thought it would be done pretty quickly. Maybe not a week, but like, I didn't expect to see a year there for some reason. But I guess it's because the people were writing in assembly there, right? It was a lot more difficult. That makes sense. Like, what was it written in? In assembly? Or, I mean, no, there were other languages before C, right? What was C originally written in? In assembly. Yeah, that makes sense why it takes 4 years then. Syntax parser. Hello, Loop. Can find program and scope. Okay, so program here is supposed to be the IR program. Alright, it's going to compile. Nope, it will not. This returns... Oh, wait, this should not return... Yeah, this is adding source. It actually returns nothing. This is the function that returns the program. Yes, we like add the sources. So in the CLI, what we do, we just like... let's see. Let's do this directly. So we have path. We are reading the path, source path, file path. We are reading the source. We are compiling. Compiler compile. We say that compiler is mini compiler init outside of this loop. Then we say that we compile in the end. And all of these paths are going to be added to the compiler. Mini compiler add source. Right? Ord map. Use STD collections. Ord map. All this waiting every time we compile. It's been a while since I do that. Hello, Bad Cop. Hello. Did you know, Bad Cop, that Bash stack is down? Miss Rust now? Yeah. This is like reminds me of Rust a little bit. Although I guess in Rust, when I'm just missing something in scope, I would not need to wait for 20 seconds to realize that I have forgot to import something. Right? With Rust, my bootstrap would probably be running faster. Yeah, maybe. But at the same time, in my Rust, I did like use a lot of like boxing and things. I think it would not be running much faster unless I would be writing the code in a different way. Yeah, the bash stack was down. It's up for you. Well, it was down earlier. It's not actually bash that's crashing, it's caddy that's keep dying. I see. I think like yeah, see, like there is no first redeem right now. Yeah, like how is the first? We are specifically talking about the first bash stack, not just bash stack. Right? I think this thing is down. Is it back up? You kicked it? Yeah. Is it like what? Yeah. Wait, what? But we still don't have the first redeem. Isn't it supposed to appear then? I don't know how it's implemented. Isn't it like the bot that is creating that redeem when the stream is running? Is this not the correct URL? It missed the online stream event. Oh, it's like waiting for the event. So if you restart it, then it doesn't pick up if the stream is live, right? But it was not live when it was like line. Yeah. Maybe. Field compiler is not there. Mini compiler. Root scope. Hold on, we need to do this. Current scope. It's a little bit weird here. I feel like we need some like way to like because I called this mini and then we have mini over there, which is the library, right? So in Rust you would say like colon, I guess, but we need to somehow to go to the root stack, to the root scope. I can just assign the scope to a variable though, so. But I feel like we will want a better solution. But what should it look like? Because I cannot just say like dot in the front. That would be ambiguous syntax. and subcommand should be mini argst. All right, it compiles. Let's see what's going to happen. "27 seconds now to compile, huh?" Oh no, I just added like 7 seconds to compilation time by adding the minicast. It's like third of, like, I didn't even write any code yet. No, it's going to be so bad the further we go into this. I need to do the incremental compilation, or like another option is parallel compilation instead of like the things, like when we are using the imports, we can maybe like compile those in parallel, but that's error prone, so I don't want to have undefined behavior. Okay, cast mini, right? It's going to say expect at least one path. Cast mini, and then we do tests, mini test, right? Like this. So it's going to say pattern match is non-exhaustive over here, right? Because we need to say that compiler is compiler source with. And over here we will also say, wait, hold on, we have internal 1, 2, 3, 4, yeah. And over here we have compiler. Let me start language server first, and then build. Exhaustiveness checking would be nice to have, but it's okay. USR being env bash, Lamau, what did you expect? What's wrong with USR being env bash, Athana? Unexpected top level item over here. Const add, that's right. I was like, oh wow, someone doing tests, unlike Kuviman, for example. What's the test? I don't think this is a real test. Oh. Yeah. Athano, if you need to test, if your code has tests, just call Athano. He's going to find your tests, or rather the absence of them. Hello, Nerdsoul. Okay, so this top level item is a function, so I want to maybe change the syntax a little bit of the mini cast here, right? So this is the function, which is basically a closure. I want to have instead how about we say actually top level function? Is that what I expect? A top level FN? Top level function. Because then we just, I'm just going to have the function keyword here, right? And this definition is going to be still the lambda syntax, the closure syntax. You have tests, but you don't CI them? I actually do CI them. Look at this. Look at this. I have the success on my CI and on the self-hosting. On the self-hosting, I have the failures actually. I just do this. Nix develop command just test, and then it just does the same stuff. What's the error? All tests passed. Wait, hold on. All tests passed is something that is... Oh, that's just like the output of the Laxer, I see. Unexpected argument parse syntax rules. Oh. My test is just written incorrectly. Hold on, just file. Parse. Yeah, this should be like with a dash. Instead, right? There we go. Fix test. Let's push. Bum 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 bum. Do you need help writing tests? I mean, if you want to, yeah, sure. You can write tests for Laxer and Parser, I guess. Since that's all that we have. Or do we, like, also test... I mean, yeah. Tests for Laxer and Parser would make sense. He was thinking about the bootstrap, though. Oh, the bootstrap? I don't know. I mean, you feel free to do that. I don't want to touch bootstrap if I don't have to anymore, though. Okay, so we have unexpected top level item. So now we say that this is a function. Function. And we say function. Should there be a space here, actually, if this is always going to have parentheses? Probably. Let's just always have parentheses there. Ah, it's okay. Let there be space. You'll add tests to self-host. Okay. All right, so this now says expected a string literal on the option tag. Oh, because no, the name, it's not as a string literal. That's not the thing that I expect. Compiler. We need to expect expect identifier. So this should be still a token, which is an identifier, which has name, and then we return the name of it. Expected an ident. There we go. How are the Siven types going to be erased? Because I'm adding a union instead, just like in C, right? So I'm right, like how do we represent the some types in JavaScript right now? We just have the tag field and we have the value field, and the value field basically is a union, right? So the same would be if we transpile to C, and Golang, which is another compilation target that I'm considering. How do you do Golang tagged union, actually? They don't have it, right? We just you just use polymorphism. Do you just use interface, an empty interface there? Idiomatic. The marker method to close the interface. Oh, this is so cursed. But I guess like that's what we could do, right? So you just have a struct, you have the interface, and then like, yeah, then you don't have a tag actually, right? You like say that, yeah, you switch the type of the value, because that's what you can do in Golang. So the type is already the tag in that case. But we can also just like cast it, right? And based on the field. Is that going to be less efficient? Is this like reflection or something? This is type, I mean, this is runtime type reflection, right? But I guess like the type at runtime in Go is just basically the type ID, right? So it's just a number. That's what I'm guessing, right? It's like, you know, in Java, it's like the type of operator in JavaScript, I guess. Or something. It's type of reflection. It is, right? Like, I don't think you can get all of the fields. So like, it's not full reflection like you could do in Java or C#. I think. I don't know. Do you think I should still have these sum types because of that? Because that I could do it like this instead? Right? Because otherwise we literally just say like what? Like void star. Golang interface are fed pointers, which probably just checks which vtable it has. Yeah. Yeah, so like, yeah, I guess it's not even, yeah, the number is the address of the vtable then, right? Or something. Yeah, could be how it's implemented too. It doesn't really matter much. But yeah, like, I guess it would be like a little bit inefficient if I like compile the sum types to actually still be a struct having the kind, having the tag field, and then the actual data is like the void star, which is the empty interface in Go, right? So I just do this match based on the extra the other tag, and in the specific cases we get the data by like casting, which is going to instead, which is basically an extra runtime check. But I think it's fine, probably, right? Maybe. Or do you think I should keep the sum types? I don't know. I was thinking that I shouldn't. To make it even simpler, but read chat. What will you do about unbounded row values, like just a single occurrence of brat2? What do you mean? What to do with them? The difference between C unions and Golang emulated unions is C unions have no interaction by default. The size is just the largest of the variant. Yeah. You cannot do that in Golang, right? Like in Golang, you have to go through the interaction. Is there... Boolean does not have union or some types. Wait, no, you can have structs with enums. The tag. Oh, but this is like wasting memory, right? Is that what people do in Go? Because this this over here gets rid of the indirection, right? But it also wastes memory. Less memory efficient. Utility generates strongly typed union with support for JSON marshalling and exhaustive pattern matching. C++ unions are actually quite messed up. What is messed up about the C++ unions? They do have an active variant. Yeah. Do they not have it in C, the active variant stuff? Not sure, you don't think so? I think that's what I will have in minicast also. I will have the active variants. And like accessing the inactive variant is undefined behavior. Zig has this also, the active variant stuff. Yeah, so and in debug build it actually like knows which one is active. So in debug build the Zig union is actually the tagged union. It means that GLM, a very popular OpenGL math library, is totally undefined behavior. Yeah, because like people do use the unions to basically treat floats as integers, for example, but technically it is undefined behavior, right? In C++. So you have to do explicit casting instead. Like calling .r and calling .x is the same, but that's already illegal in C++. Does C++ have something similar to the Rust's dref? Because in Rust, you do have the option to have like .r and .x being the same, you know? And I do... I do the transmutes there, but I'm pretty sure that what I'm doing is safe. I've seen other libraries do that too. Well, so in C++ they do it with unions instead, right? In general, always having a top-level struct and only having unions within its fields is good practice. In Zig or C. Yeah. Sure. All right, what am I doing here? Kast mini. Unexpected top-level item. Yeah, this also needs to be a function. Okay, there we go. So we have compiled this file. I mean, we have parsed it. We have parsed this. And we have parsed this. And now we want to compile, right? So we want to go. We have collected in this state the top-level items, right? So let's start by parsing the types, right? So we say for item in state top level items. So we basically do a 2-pass compiling. First, we figure out what are the all possible names. When you get bored of minicast, you'll make microcast or nanocast without extensible syntax. I mean, minicast also doesn't have extensible syntax. We do a 2-pass. First we like see all the names and all of the types of the names, right? I guess. So what is the types of all of the functions? And only then, after we know the types of all the functions, we go into the bodies of the functions and we compile them, right? Because then we can type check, is the idea here. Okay. So we do iterate here. And we say match item with, if it's a type which has so for now I just care about the name in this first pass, right? So I will have in my compiler state, I will have type names, which is just a set of strings, like what are the types that exist. Why have an IR in text and not a binary in memory? For testing, no, we will have it binary too, I suppose, right? But because like I can just use the existing parser, it's easy. Well, I mean, I guess, yeah, maybe we can like convert the AST into the intimate representation, which is the thing. Yeah, I do I mean, right now I don't parse twice because I just give this like it's like the textual representation, and we can have an alternative binary representation, I guess, right? Yeah. So this should not expect the AST. It should expect something different. So that when we... Yeah. I think I'm okay with parsing twice, though, for now. We can change that later. Types, type names is ord set new. So over here we just say state type names set add name. That's all. If we have a function name, so but for the functions we will have to like also like figure out the type. We didn't get a full rewrite, but this is close enough. Okay, so now let's just do the types first, right? So now we know the type names. Now after that, we are going to do a second pass, which is going to actually do the definition, right? So the program has the types, which is like name into the definition of the type, right? So we will have a name type. Let's have type, and over here, you know, what do we call it? Not compile type, but like process type. So process type is let's do this. Name. Kind. Definition. So we want to see. So I think I use curly brackets here, and over here we use the round brackets. By the way, do you think this is a little bit inconsistency with the original cast? Because we use the round brackets for the variant types, but the curly for structs. For minicast, I don't really care much, but should it be this? Maybe we should allow both, you know, so that it doesn't matter here. I don't know what I want, but it's a scope or a record. Is what I want. So let's see, match definition, shape. Dun, dun. If shape is a rule, if rule name is equal to, like, this is where I am getting the inner, right? I mean, I'm getting the actual. Let's just override the definition. Rule name is core scope record. And then, I mean, actually, or rule name is equal to core scope. I don't need to like say that these are core because everything is core technically. So yeah, I can do like in this mini syntax because like we don't have the macros anyway, right? I can just do that. Because we just say if def shape is rule, and then if the rule name is record and scope, then we return root children tuple unwrap unnamed one ast unwrap child value, and then we return that. And over here we say the diagnostic that we report. We say that expected this or that, you know. Sure, let's do that. Definition span. Okay. So this is definition. We just like unwrap the braces here basically. Now we have the definition, and now we will do something depending on the kind, right? So we'll say that match kind with, if the kind is in enum, then I need to go over the variants. Ist iterate a list. The definition should have the binary rule name, which is a union. And then trailing or leading rule name is a leading union. Is that what it's called? Leading union, yeah. So it's a 4. So this gives me the variant for variant in this. Now every variant must be a colon, unless I do. Maybe I feel like I still want to require the colon here. Do I? Yeah, I think I do. So this is variant without value is what we expect there. Dun, 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 dun. If the rule name is variant without value, then we just get, this is not unnamed one. We should tuple get named, it's called label there. So this is the variant name basically. We want to have a variant we have children get name. This needs to be a reference, so I need to dereference that, then unwrap child value, and then expect identifier, and this will give me the name. Expected colon variant name, you know. So now that we have the variant name, we just add it to the variants, right? So we have the type definition. The type definition can be an enum, right? Which has variants, which is basically just a list of strings. That's all, right? So we have just the names of variants. And I guess I will have over here the actual result, which is program. immediately. We'll start to construct it. So when I compile, so we just return the state program here. And this is what we do. We have no types, no functions, empty main. Well, wait, we don't have even main anymore, right? Because we just will have the function called main. If we need to. So now that I have the variance, right? Let's extract this to a function, right? Process enum name and definition. Process enum name definition. Like this. This over here. Let me also, yeah. Let me do this. Expect rule with single child. Right? How about this? So we have the AST, which is AST. Rule name. Then this must be like a singular rule name. You know what? Let's just do a record. You know, let's just do curly brackets there. Just do curly brackets. Rule. And child's name is going to be an optional string. Yeah, there we go. So this should return the AST of the child. Right? And maybe like the expected error message, you know, that's what we're going to do. So this is going to be that, and we say this. What does accepting the non-active union have to be UB though? Like, I don't get it in C++. For, I mean, doesn't it, I don't know. Well, I mean, I will make it the undefined behavior because, well, I mean, what do you think should be? Like, should it be not undefined behavior only if it is like what? Like, I don't know. I feel like it should be undefined behavior. Why is it a thing? Because, like, you have only initialized the data of a specific variant, right? Which means that the data of the other variant has not been initialized. If transmute is fine, then it should be fine. Yes, but, like, why add this rule, right? You can just say that it's never fine, because that's a simpler rule than allowing if transmute is fine. That is only like complicating the language even further, right? And both C and C++ are abstract over the byte representations of some types. Yeah, I guess like that's the reason why I do that, because I'm abstract over the representation, especially because I'm like abstracting over the backends such as JavaScript and C at the same time. If AST shape is rule, if rule name is equal to rule name, then over here we say let child be match child name with none. Then we say root children unwrap unnamed one, and if it is some, then some name, then it is root children tuple unwrap. We don't have unwrap named one, right? Yeah, let's just say tuple get named name. This needs to be and this needs to be also option unwrap, right? So we have a child, and then we return child unwrap child value. Otherwise we do diagnostic, and over here this is the error message in the span. So over here the definition is expect rule with single child, right? So this is the definition. A rule is record. Error messages expected this. Child's name is none. Okay, there we go. And this over here, variant name is expect rule with single child. Variant. After that, so this is going to be the C, so we expect identifier. Variant rule is variant without data. Child name is some label. Error message is expected variant name. So okay, now this just simplifies the code a little bit. Now we have the variants, right? And we just say that type is enum with variants, right? And we say that state, we will say context, current context. We just say context program types or the map add name type, right? There you go. And then we want to process, so we have enum, we have union, and we have struct. Process enum, process union, process struct. We have enum, we have union, so union has, do we also call it variance? Struct just has fields, which is wait, should this be an array list? This should be like a set, right? So that we can like compare them easier. for type checking. I don't think I care about preserving the order here. Modern unions are tagged. So union is going to be an ordered map then from string to a type name, right? And then struct is a field which is ordered map from string to also type name, which is very similar to a union. So we actually should do process union and structs in the same way. I think process struct for union, and I will pass the kind here, right? Because we will have the fields. Wait, this is enum. This is going to be variant. The ord set, and it's going to be ord set add. Right, process. Structure union. Structure union. Kind, type kind. So we just have like, we call it fields, ord map new. So this is going to be not a rule with a single child, but with 2 children. So I feel like I will have to do a rule with 2 children again. 2 children. Children names is an optional string, I think. And this returns me 2 ASTs then. So it's just about how we do this, right? So yeah, we say like A and B here, right? And over here we say A and B unwrap child value. If we have a name, so this is names, right? Name A and name B. So this is unwrap unnamed 2, and this is going to be let A be that. Let B be that, and then we return AB. Okay, so we have fields and structure union. So this is going to be an ord map, right? We're just going to say that type is going to be over here match kind with if it is the struct, then we return struct with fields. But if it is a union, then we will return a union with variants, which are fields, right? In any other case, unreachable, because it's supposed to be structure union here. So over here, I want to have a name, and type. Right, so this is going to be field for field in this. This is going to be comma, and this is going to be a trailing comma. So now we say that name and this is expect a rule with 2 children. The rule is called field init. And I think we don't do the type of script. Wait, hold on. Let's do this. We do field initialization, which says dot label is equal to value, right? And then we have the field type, which is different, which is going to use the colon instead. Field label is type, right? So this is what we do for initialization. This is what we do for type, right? And we don't have the inline field or whatever. Yeah. So over here we say field type. Let's say field definition, I guess. Field definition. Right, so child names is some label and type. Right, and so over here we say expected dot field name field type. Dot name type. Expect ident. No. We say that name is name. Expect identifier. But type is just a type. But I guess type is also just an identifier. If we only have like the simple types ever. For now. I will need to have some complicated types though, right? Like if we don't have the generics. Like I still need to be able to have a reference type and maybe like array types. So those would be hard, like a little more hard coded, right? Let's say type is type, also expect identifier for now. So we say that fields, we add the name and this is the type name, right? And this is the type name, which just has name as this, right? Name type. Okay. So I think I should be able to figure out all of the types now. If this compiles. What do I even have specified in this test? Or set is not in scope. In the test. Like over here, right? I'm using the union, the unit. And unit is not a name. So I have to like either make this the special type, or we can name this the unit type. Maybe we can just name the type to be unit. I feel like for minicast this is okay. If we just say const unit. But what is a unit, right? That's another question. So this would be the... I guess like it's supposed to be an empty struct, basically. Boom, 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 boom. Ideally, empty structs are not really there, or are they? Hold on. It depends if I do the AST iterate over the list. Oh yeah, no, if it's empty, no, it's fine. This should work. State is not immutable. What's the goal with minicast? Simpler compilation? Yes. So like, because rewriting the casts from scratch fully, the self-hosting, is going to be a lot of work. We instead do something simpler, and then we will do the bootstrap, which compiles to minicast, and then the self-hosted minicast is going to compile it further to the actual target. This way, we can speed up the compilation without touching the code of the bootstrap. No, not speed up the compilation, speed up the runtime by fixing the compilation of the minicast instead of fixing the compilation in the bootstrap and touching that code, you know. But it will increase the compilation times, yes. Actually, it will. I feel like I will have to work on the incremental compilation at some point. We will get to like 2-minute compile times, and then that's probably when when I say that it's enough of suffering. This should be like type. Slow just causes another IR to process. Yeah. Child name is not in scope. Child names. Maybe it's like, maybe actually, if it's going to work, then it's going to be only the first compilation that is slow. Because if we actually make the backend for minicast to be fast, then probably compiling minicast is going to be fast. Probably. But still, like, right now I'm generating the... I'm generating 80,000 lines of JavaScript, and it's going to be very similar to that. So we need to, like, how quickly can I compile that if that was minicast? Maybe I will generate less code, actually. I don't know. We'll see. It's children names. Should it be child names or children names? Child names, right? Because child name is the singular, and plural will just add the S, of course, right? That's proper English. Even although it's multiple children there. Wait, what is actually proper English? Child names or children names? Children names. Well, in programming, this is correct, I'm pretty sure. Field. Should simplify compilation to other languages, less lines of JS, hopefully. Yeah. Yeah, that's the goal. To simplify compilation to other languages, yes. And maybe we will do Golang instead of JavaScript as the first minicast target. Expected variant name over here. Wait, but it is a variant name. Hello? This is a variant name. Expect rule with single child. Variant without data. Hold on. Syntax. Variant. Oh, it's variant without value, of course. I mean, we can call it just variant if we don't have the data, right? Just call it variant. There we go. It is a little more complicated to generate the minicast compared to JavaScript, actually, because we are going to specify the types. I still want to have the types here, right? I don't want this to be an untyped language. Expected name type over here. But it is a name type. Oh, yes. I need to colon, right? Because we're defining the type, not that. Yeah, okay. There we go. Okay, nice. Look at this. We have this stuff. So we have So option data is a union with a variant called sum, which contains a unit. Or none, which has an int32. Wait, did I mess it up? Wait, it's supposed to be the other way. None is going to be a unit, and sum is going to be like an int, right? Well, having this without the generics, this is the difficult part. When we don't have generics. How would I even compile this? It's almost like I should have an any type. Wait, maybe instead of a unions, we just do the any type? No, we want to have the union. Are the generics monomorphized? No, not yet. They are not. And they will not always be monomorphized, because monomorphization is taking time. We don't want to do that, actually. So the way we do it in like current compilation to JavaScript, right? When I have, I mean, in JavaScript, we don't specify the types, so it doesn't matter, right? We're basically just assuming that the types are correct. But we have the runtime type information also, a little bit of that, if we do need something that is specific to a type, like a trait implementation. I mean, I could definitely like have the type information as a type in the mini cast here, but how do I compile the code? Like basically what we want, like, so when you compile the generic function, what you do instead is, so over here you have generic function. It's going to be a function, right? That like say returns units, right? And this takes, so t over here is going to be the generic argument. So this is the type. And at runtime, instead of a generic type, we have the runtime type argument called type information, right? And this is the actual argument of this type, but this depends on the runtime. This is the process that's called existentialization. That's what Swift does for generics. But how do we represent this? Like, let me show this. Existentialization Swift. This is the one. Existentialize your generics. So you have the runtime information about the type at runtime, right? So languages like Java keep value and the type information like next to each other, right? I guess like the similar to how like they do it in Go with the interfaces, right? They are just like every value is basically a fat pointer or something. But you could instead do existentialization where, so here is the C code, right? Hello, what? I'm scrolling in the other direction. And to press this button. Right? So you have type float. So for every type, you know how much size it takes in memory. And you know how to copy and how to drop it, basically. That's like the important things, right? And then when you create the function, right? Like over here, this is the code in Swift, right? So you have the interface shape, basically a trait in Rust, right? Or whatever, which has area, which is float. So you have a generic function which takes a shape, two shapes, and calculates the one with the smallest area, right? And returns the shape with the smallest area, right? So how do you compile this without monomorphization? Well, you just say that your type T is also available to you at runtime. You also have the shape itself. This is the trait, which is basically the virtual table, right? The v table is also passed at runtime here, So X and Y is just void stars, literally. Because we don't know the type of it. And then R is the return type, because we don't know the size of the return type. So it's going to be the callers. It's going to be the caller who allocates the memory for the result, for the return value of the function. And this is the return type, right? And then you just compile it once. And over here, this is just saying return Y. This says return X, right? So you copy the type from R to Y, or from R to X. And this keeps your types still to be like efficiently represented in memory. It's just there is a little bit of the overhead on calling the generic functions, right? But this helps with compile times. Because you only compile every generic function once instead of 1,000 times. So they say void star, but this also is the things that get allocated on the stack. This, like, it has nothing to do with the heap technically here. So this is why I say we want the any type, right? Because we cannot say that this argument is of this type in a simple language like C or whatever. But like if I compile to Go though, then it is going to be a little bit weird. But I guess we do this only for generic arguments. For regular arguments for which we know the type, which is not generic, we will still pass them properly, I suppose. So the argument in this case is any, which is technically of this type. But we don't have this information in the type system. Is what we want to do. Which means that we want the any type, which is void star in C. Which is an empty interface in Go, I guess. InnoCamel is an obj-t, I guess. By the way, InnoCamel, you get the obj-t. Well, I mean, yeah, InnoCamel, yeah. Yeah. In Rust, this would be what? The boxed in any? Or something? Right, so we actually lose the type information, but that's okay, because that's going to be like the generated code. But then we need the casting operation from any to a different type. Do I? I'm not sure. Let's ignore this though for now. But that's what we will do for generic functions. Let's actually do this exact example that they're doing here. Or what do I want? No, it's not. Let's not write code actually yet. But we will have type info, which is a struct. We'll have the the size in memory basically. Wait a second. We don't want this to be this. We don't want to calculate the sizes yet, actually, in the minicast, I think. Do I have generics here still? You have the generics in current Go anyway. Right? The simple ones. You just cannot have the trade bounds. right? How do Go generics work currently? Go generics. No, you do have something like comparable or whatever. Or you have like the ors. I don't know, generics is a big complication. I don't want that, probably. Let's not think about that yet. Making a simple language is difficult. Apparently. I just need to figure out what I need. But yeah, I'm pretty sure that for any type that is generic, we just convert those types to any type. But like, so if we have in regular Rust code like this, right? We have implement string as, I don't know, we implement int32 as parse, right? Which is a function which parses an int into string, right? Which is some implementation here. And then we want to like create the actual function parse. So parse is t string into t, right? And this is just t as parse.parse. That's what like we do basically currently. So how would we convert that to the minicast? We say that parse is a function taking t. So this will be like some type info. So in Swift they pass this as argument. Or we could instead say like so this is like parse t as parse, right? Is get parse get cast implementation. That's what we do of t to parse, because parse is technically also just a type. But parse is generic type. Parse itself, right? So parse trait is this self type parse self into string. Right, so we don't even have the type information about this, because this type, we also never monomorphize types. But how do you do this. How do you do generic types also, right? Because we need the type information then at runtime. So that is when you create, like you say instantiate parse. So like for a generic type, we will call the we'll have the instantiate, because this is just a function, parse t. This will have the type. That we want. Oh my god, no, this is difficult. Oh my god. This is difficult. So we have t-type info, we have s, which is string. This should return basically the any type, right? But it's supposed to be of this type t. So we this over here is the type, has the type instantiate parse, but because we don't know what this type is yet, this actually will have any. Like we will have to work with a lot of any's, it seems, right? Well, I mean, that's what they do in when compiling Swift too, right? Everything is a void star, basically. Anyway, so we get Kast implementation of this type. Into this. I mean, if this is a trait, this could be like trait impl, if parse is a trait, basically. But this is going to be like a function instead. So get trait impl. Get trait impl is like a function which takes the type and trait is a function from type info into well, this is the implementation. No, the trait itself is the basically type info into type info, I guess. But this returns any, because this is the type that we return. And this would be like done with the stuff at runtime. Okay, let's say that we have this, right? So we have any ts parse. But we kind of know that, so yeah, so we know ts parse, right? But then we need to have the field called parse here. So how do we get the field called parse from any type like this, right? It means that type info should allow us. Yeah, it's basically like it's basically we have a combination then of dynamic and statically typed language. It's dynamic in for generics, but it's static for other things. Right, like what we want is we want to like get field of ts parse, and the field is going to be the parse. Now this could be the interned string, which is basically a number, so it's more efficient, right? And this is like the parse. So what's the type of parse? Like, because it's get field, it's just going to be any. But we can get the type information about that if we wanted, because that information would be stored in the type info struct. but then we just like also call. So like we literally just generate code to evaluate a dynamically typed language almost, right? That's what we need to do. So I need to call parse and arguments is as. So this would be a dedicated function called call1. Well, how do we call the any? We need to know about the type of it still, right? Or something. We need to know something about it. This is the value, which is going to be like the address of the function. This over here is basically the address of the function, right? Well, I mean, yeah, and then we just have the calling convention. So I think this actually is the... I think this is the language built-in, right? So so we literally have any type which can be converted to any type. In this case, call1 is actually a function which is taking the function which has an argument any into any, and this returns any, and the argument is any, right? Like that's what we do. So it's like calls this function, which basically means that we can just cast it, right? We say that parse any into any is parse as any into any, right? In this case, we could probably infer it. So this is the casting. Now we will know this, and we can call. Nice types, bro. Well, I mean, yeah. That's what we need to do to not monomorphize the generics, though. So it's going to be a combination of a typed and untyped language because of that. But like this is the code that we are generating, right? This is still like typed language, but we just have the any type in addition, which is the void star in C, which you have to use sometimes because of the simplicity of the type system. Right? Same as with unions. You just have to tell the compiler trust this is the correct type. This is the correct union variant. Right? Because in order to make this properly typed, I would have to have like the dependent types basically again, or like generics, whatever, which we don't want to. We want to keep the language simple, so we leave this to the runtime, and it is going to be in runtime anyway. when we compile this further to C. Or to JavaScript, or to Go. I mean, we will start by just like if you don't use generics, then you will just have the typed code and like everything is good, right? Boom, 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 boom. It is what it is. Well, I mean, that's what Swift does, and Swift is a fast language, fast enough, right? They do monomorphize sometimes, but not all the times, right? Like only something that is very, very simple to monomorphize, I think. Similar to how C inlines some functions, right? But you don't inline everything everywhere. Are you going to focus on cast minicast or minicast some backend first? I don't know. Maybe we can also do the first backend for minicast to be the interpreter. Maybe. Interpreting minicast. And maybe that's something that I don't need to do though. Maybe like the first target would be the JavaScript still, because like we have existing code which is glued to JavaScript, right? Doing a different backend would probably be more work. So yeah, maybe we just do to JavaScript. And to JavaScript is easy because we don't need to like convert it to do the types, right? We just need to do the functions anyway. Yeah. All right. How about this is a good start? This is a good start. The birth of minicast. Okay, but I'm going to continue later. I might come back later in the evening today. We'll see.
Those bug was in the pull request. Oh wow. A whole month. 100 pages of A4. I heard Malaysia, you were out doing something and sprinting back on. I was talking about how I went to
Signal.
Let's go here. Hypnotic games.
Object held.
Thank you guys for watching. See you next time. Bye.
Oh, thank you for the follow too. Much appreciated. Make sure this